I'm Lili Xu, a machine learning software engineer. Welcome to the new advancements to logistic regression and machine learning library. Let me first introduce machine learning library. So we have two base bundles, which are machine learning core bundle and PB+. They're the dependencies for the rest of the machine learning bundles. ML Core is the utility bundle that help you transfer the raw data into machine learning formats for your models. And PB Plus is the parallel Plus library for large-scale matrix manipulation. We also have Preprocessing Bundle to help you clean and transform your data for specific machine learning models. And then we have a set of supervised and unsupervised models. For example, they are commonly used for our linear regression, learning trees, k-means, and text vectors. We also have GNN, which is a deep learning model to developing cutting-edge AI bundles or applications. And the last but not the least, we have a new bundle called Causality Toolkit. It's going to be introduced by Roger in the following sessions. A quick poll here. How many machine learning bundles have you been used in your work or study? The first advancement is logistic regression bundle. If you are from a machine learning family, you may know that it's a commonly used or go-to classification machine learning bundle used for supervised learning. So one example here is we are using maybe smartphone or smartwatch. We have the data for the user's daily activities, how many hours he sleeps, and the coffee intakes, focus time for study or learning every day. If he have workouts or does he eat lunch. So all this has been recorded, and then we fit into logistic regression bundle to predict if the user is productive or non-productive. So this is a simple one example, but logistic regression has been widely used in different fields, such as financial fields for credit scoring. In medical, we're using it for cancer prediction, etc. And we have two basic scenarios for logistic regression. The first one is a binary case. So for example, we have the input data, our emails, and then we have a binary classifier to predict if the email is a spam or not. So as a result, we using this binary logistic regression bundle, expecting only two results, spam or not. In contrast, the multi-classes classification task, we're expecting more than two classes. For example, here we have a data is a handwritten digits, and we have a multi-class prediction model to predict the data or the handwritten digit is belong to one of the categories here from 0 to 9. So you may wonder then how about our own HPCC Systems Logistic Regression Bundle? We have all of it. We have both binomial and also multinomial logistic regression. And more than that, we have automatic selection function to help you select between binomial and multinomial regressions so that you don't have to manually flag the selection between these two models. And also maybe you are not familiar with the binomial or multinomial logistic regression. And some user may ask, what's the difference between linear regression to logistic regression? Both are regressions anyways. And that's a great question. So one example here in the picture shows that we have two classes here, 0 and 1, two classes. We can see that when we're using logistic model regression line, the data points has been clearly learning in the sigmoid function, or we say it's a logistic regression line. When we're using a blue line, which is the linear regression line, the data cannot fit as good as a logistic regression line. And also we can tell that the data, the target Y is more discrete distributed. And in linear regression, we're expecting the data points continuously or continuous value spreading along this blue line. So hope it give you a more intuitive way to choose the model between linear regression and logistic regression. If you have any questions, please feel free to ask me in the chatting window so I can answer the question by Bob to tell me if I have more questions coming in. And one poll here is, what is your go-to classification algorithm? The next advancement is pre-trained model in GNN bundle. So quick poll here as well. Have you heard of deep learning model GPT-3? The GNN bundle is a deep learning bundle, as we know that in the modern world, deep learning has been widely used in different areas or domains. For example, in computer vision, in this picture shows that we can detecting instantly in timely manner of the dancer or athlete's movements. Also detecting the busy highway or a busy shopping center, the crowd and the traffic. Even detecting the objects in the moving videos, like cars or a person is walking or running, even detecting specific person's face in the videos. So these are awesome applications all using deep learning technique. And that's why we have this highly scalable GNN bundle to helping you developing deep learning applications on top of HPCC systems. And we have a strong backend using mostly supported and widely used deep learning framework, TensorFlow and Keras. And we have also user-friendly front end. Basically, you can use the exact same syntax from TensorFlow and Keras to define deep learning models in GNN. So deep learning is the key instruments of AI in the modern technology world. It moved the needle forward for many fields, especially in the computer vision and natural language processing fields. In a summarize, we have some cutting edge bundles or models that can presenting the advancements of modern deep learning, for example, CNN, BERT, GPT, and it also advancing the fields that may even exist in the past. So here we have using a model to training and using tons of images to apply artist Van Gogh's drawing style in the Starry Night to the modern picture, the city of a London skyline. So on the picture B, we see we reapplied Van Gogh's drawing scale into modern pictures. And that's a branch of art called neural art. Even fancier, we are using deep learning in natural language processing in an intelligent way. It's called GPT-3. It's the most state-of-the-art model for natural language processing. So here's one example. A user says that it is mind-blowing when they're using GPT-3 to creating a layout, just describing what you want in your layout. And GPT-3 will automatically generate the code in JSX. So here's one example. The user says, in his own language, a button that looks like a watermelon. And then it will automatically shows you a JSX code, and then a layout it looks like just like a watermelon. So that's how GPT-3 works for just automatically using natural language processing a code or layout. And one example here is using GPT-3 to automatically put on caption for pictures. So in this application, we can just upload pictures and then it will automatically, almost instantly creating a caption for you. For example, here it shows that in the picture, a group of awesome people are competing in a Christmas dinner competition. So it's awesome people here, which is really some kind of like a human being, how they describing a Christmas dinner type of thing. So we see the here using GPT-3, we have a lot of fancy intelligence kind of show up in the deep learning field. So all this fancy deep learning, then what's the rest thing about deep learning? There is a lot still going on behind the scenes. This all depends on the deep and complex training for those neural networks and take a lot of time. It's time consuming and expensive. In GPT-3, we're training about 300 billion tokens, and they're training 175 billion parameters. Imagine where our last model, logistic regression, we have less than 10 parameters. That's a comparison of this deep learning model to the traditional machine learning models. And it trains on 10,000 GPUs and spent billions in investments. So now the question is how we can train deep learning models or applications more efficient and cost effective. The answer is using transfer learning. Transfer learning is a type of technique to transfer your domain knowledge. For example, here in a picture on the right-hand side, we are learning from some domain, and then we're using the domain knowledge stored in the weights or in the model, and then we apply the new data from a target domain to get a target model. In this case, we are training way less data than the traditional machine learning on the left-hand side. Left-hand side, we have to train different models for different domains. If we have 10 domains, they have to train 10 times and cost 10 times same amount of money or even more. That's why we think it's important to get pre-trained model into GNN as a new feature. So in GNN, you can using a open source pre-trained model such as VGG, ResNet, and then repurpose the model using, for example, in the picture, some trained model. We have different convolution layers and pooling layer here and there. It's a pretty long process, but no worries, they're all trained, and just use the weights in their model structure and then remove the layer that you don't really need. And then insert your own layer, such as here, we're using softmax 3, the 3 class softmax layer. It's pretty simple for your own task. And more importantly, now you can use way less data to train your model. So a lot of time, getting data is really the hard thing in the world. Like you don't think that it's the hard part, but in some domain, the data is just impossible to get, like billions of tokens or billions of pictures or even voices or sounds. So trained model with less data is very helpful to building certain kind of applications. And last step is fine tuning for your target tasks. So that's how we're using pre-trained model in GNN. If you have any questions for this, please feel free to ask in the chatting window so I can answer those questions. The next advancement is Preprocessing Bundle. Here, a quick poll here. What's the most used pre-processing technique in your study or work? In our bundle, we have different kinds of tools, and we try to make them more scalable and efficient. So we still have the encoder, scaler, normalizer, samplers, but those are not more scalable and efficient. Importantly, some user may ask me, what is one-hot encoder? And actually, that's one of the most used tool in our preprocessing bundle so far. So I'll focus on introducing one-hot encoder and the comparison to label encoder here. So one-hot encoder, we make it scalable and efficient, and also realizing the interface is a Marietta interface in HPCC systems. So how we use one-hot encoder here. So if you are from a statistical background, you may know that it's basically a dummy variable converter. So you are converting a string-based feature or a variable into a machine-readable 0-1 encoded fashion data. So in here, 1 means A 0 means non-present and 1 means present. What I mean is when we transfer the categories into 0, 1 encoded fashion, 1 means the feature is present here. So cat, for record 1, it says it is a cat and it's not a dog, it's not turtle or fish. So it's all 0 for these 3 categories, only 1 for cat. And for second records, a dog, so only dog encoded as 1, the rest are 0. That's how one code encoder works. In comparison, label encoder is not like that. It just simply transfer your text into numbers. For example, we have safety level here in the left column. We have none, low, medium, etc. And then we just simply transfer the strings or text into numbers on the right-hand side, the 0, 1, 2, 3, 4. But actually, you can use any sequence here for your tasks. For example, 1, 2, 3, 4, even 10, 11, 12, based on your own applications. But that's the 2 mostly used tools. So far, I got the feedback is one high encoder and label encoder. If you have more questions about this bundle and the tools, please feel free to ask me questions and I will answer the questions. The last poll is here is, are you interested in using HPCC Systems machine learning bundles? And last, we have some more details about our HPCC Systems machine learning library. Please feel free to go into the links to take a look. I can post the links in the chatting window so you can go there directly. And last, I will welcome you go into our machine learning booth. Thank you so much for coming here, and I will see you in the machine learning booth.